Yes, beta. Now I'm going to teach about solenoid. Very important topic. Let's discuss this very thoroughly, beta. See, the current carrying conductor, the current carrying conducting wire, which we are calling it circular loop, we saw two things in that. First part is if we are increasing the amount of current flowing through the circuit, the magnetic field strength was increasing. That was we saw. Second part, what we saw? We saw the second section was, see, the second section, what we saw, beta? We saw the second part is ki the radius, the more we try to run away or go away from this, the more the magnetic field lines was becoming weaker. Understood? So, how to increase the strength of magnetic field line? For that, the concept of solenoid come into existence. Now, what is the meaning of solenoid? Solenoid is like copper, insulated copper wire is there. Okay. Now, insulated copper wire like spring, if we will take the spring and the turnings of the spring will exactly come like this with equal, this will exactly considered as a solenoid. Understood? So the conducting decrease the distance will increase the magnetic field lines. Absolutely correct. Understood, beta? So here you remember one thing. That important point is the loop number of, yes, the loop, good evening, beta. So the loop number of jo turnings are there na, if we will increase the number of turnings, the field strength will increase. Understood? But now we are going to understand what happens on the faces of the solenoid. So if somebody will say that the face of the solenoid is very, very important. Okay. So for that, one rule is given. That rule is called as clock face rule. Very slowly we are going to understand this part. It is called as beta clock face rule. So what is exactly the meaning of clock face rule? So if this is exactly the face of the solenoid and the current is moving this clockwise direction, then this part will represent what? This part will represent south pole. Understood? So south pole of magnet. This will be representing which pole, beta? South pole. Correct? So this will be representing south pole. But if the current will be moving in anti-clockwise direction. Understood? So here inside, if this solenoid anti-clockwise on the face of the solenoid, at the end part we are talking about, good evening Vendan. Now look at beta. At the face part when we are talking about, it will be exactly considered as what? It will be exactly considered as what? This will be considered as north pole. So remember this clock face rule. So this clock face rule says a very important point. Again, I'm telling, on the last phase of the solenoid, if the current is moving clockwise direction, then that phase will be considered as south. And if it will be moving in anti-clockwise, it will be, yes, and anti-clockwise will be north. Absolutely, that is coming as clock face rule, beta. But now we are going to understand about the impact of solenoid. Now, how the solenoid is working and why solenoid is considered more important than a single loop. Understood not? So now, beta, understanding one important point here is ki what is a solenoid? A solenoid is a continuous turning of the loop. Understood? A wire, a straight wire I will take, and that is called as insulated copper wire. What is the meaning of insulated copper wire? Insulated copper wire is those wires which are having a plastic coating or an insulated coating outside, and then the current will flow into it. Understood or not? So after current will flow into it, after that also they will generate a magnetic field around it. Understood? So now we will be understanding two facts related to it. So when we are protective layer will be there, means the wire will be insulated from outside. Understood? It is not a naked wire. It will be covered with a plastic. Understood or not? Or a rubber coating outside. That will be. So yes, it will be having a coating around it. That's what it is called as insulated copper wire. Now this insulated copper wire will have multiple turns. Understood? Now these turns will do what? Usually one circular loop, understand this one circular loop will be there, then it will generate magnetic field like this. So every point we can generate a magnetic field. So this will have, so if I will take one page, magnetic field will be like this. Another page or another sheet I will see magnetic field lines, another see magnetic field lines. Means one single loop, wherever we will see. यस आई नो बेटा, नेक्स्ट पेपर इज इंग्लिश, बट साइंस थोड़ा सा कर लो तुम लोग, अब डर लग रहा है साइंस का मैथ्स का पेपर देखने के बाद, ठीक है। तो नाउ प्लीज रिमेंबर दिस पार्ट कि देन वॉट एवर कार्डबोर्ड एंड शीट्स यू विल टेक, every time you will be seeing magnetic field will be generated, understood? So that means it's only for one loop. But what will happen if we will take multiple loops? If we will take multiple loops, then what will happen? If we will take multiple loops, at that particular situation, what will happen, rather than individual magnetic field lines, the multiple loops will be exactly collectively taking the electrical field and summarizing the field effect, and it will act as a magnet. Okay, then magnet means how the magnet is behaving. Just a few minutes before we had discussion, the magnet will exactly have magnetic field lines. The magnetic field lines will come out like this and it will move, so from north pole towards south pole, understood or not? So irrespective of every loop having a magnetic field, when these loops are joining together means in a string part like this and making a solenoid, then rather than having individual magnetic effect, the magnetic field lines will join together and make a single magnetic field line, understood? And it will start behaving like a magnet, understood? So this is exactly the effect of solenoid. So when the solenoid means what beta? A wire, a copper wire taking many turns, that will make as a solenoid. Now the solenoid will have two faces, one face here and another face will be here. So just we discuss the outer face of the solenoid. Like beta, if I am taking like this, so this will be one face of the solenoid and this part will become one face of the solenoid, correct now? So one will be clockwise, another one will become anti-clockwise. The place where the clockwise motion of current will be there, it will be considered as south pole, and the one which will have anti-clockwise, it will have north pole, understood or not? So it will be showing north pole, the another one will be showing as south pole. I hope you might have understood now. So till here, is it clear beta? So why we are using solenoid? We are using solenoid to get a more stronger magnet, understood? And this magnet is not a permanent magnet. This magnet is a temporary magnet. I hope children you have understood. This magnet is not a permanent magnet. This is a what beta? Temporary magnet. And this temporary magnet field strength we can increase and decrease. It is not constant. Yes, it is not going to be constant. That's exactly an example of temporary magnet. Understood beta? Everybody please understand this part. So beta, every single turn of the solenoid is a single loop. But when these loops join together, the magnetic field also join together and it makes a wider magnetic field. Understood? Depends upon current flow. We will discuss about this. So it will make a wider magnetic field, and this wider magnetic field will act as a single magnet, understood? It will act as a single magnet beta. I hope everybody joined together. Now we are going to understand about solenoid in much detail. First thing about solenoid, what we have understood beta, one single loop is one turning. Like this, multiple loops when we are taking, it will come as a solenoid. The solenoid will have how many faces? It will have two faces. One where the current will be moving anti-clockwise will be taken as north face, and the one which will move clockwise will be taken as south. Understood? So it will act as a magnet. It will act as what beta? Magnet. So just draw this part. Done. So once we are drawing, Just we will try to understand this behavior. I'm trying to draw the circuit. Done. Now beta, here we need to understand that one will be clockwise if it will go like this. Understood? So here this part will act as south pole, and this will ultimately become north pole. Understood? So one will become south pole and another one will become north pole. The current will exactly move like this, means the magnetic field lines will start from north pole and goes towards south pole. Yeah, north to south. So here it will go from north pole towards south pole. I hope you might have understood better. The magnetic field lines by the current carrying solenoid is similar to the magnetic field produced by a magnet. Understood better? So just remember this one. When it will be clockwise, the loop will be in which direction? Clock. Then it will make what? South pole. Anti-clockwise, if it will be, means it will make north pole. Understood not? So north and sorry, and I wrote wrong. So here it will come as north pole. Got it? Anti-clockwise north pole and clockwise south pole. This is about basic का एग्जाम दिया था दामने. Now look here beta, certain points to be remembered. कैसा गया एग्जाम बेटा? So now certain points to be remembered. That magnetic field strength depends upon few factors. So what in all things the magnetic field strength depends upon? First note down the strength of magnetic field produced. The strength of magnetic field produced. The strength of magnetic field produced. कैसा गया बेटा? Yes. क्या बात कर रही है? The strength of magnetic field produced by a current carrying solenoid ये तो गजब कर दिया. Depends upon few factors. So solenoid depends upon few factors beta. What and all are the first few factors we are going to check about it? First, the number of turns in the solenoid. First is number of turns in the solenoid. Number of turns in the solenoid. Greater the number of turns, more the magnetic field. So that means what? Greater the number of turns, more the magnetic field strength will be. So that means magnetic field strength is directly proportional to the number of turnings. So magnetic field strength is directly proportional to number of turns in solenoid. Understood? So how many turns will be there? Greater the number of turns, more will be the magnetic field lines. Understood? Now, second point, it is depending upon strength of current. So that means MFS, magnetic field strength, is directly depending upon current. How much current you will increase, that much strong magnetic field lines will be. Understood? And it is inversely proportional to the radius. Understood? Now, got it? This is the two things. Radius, if the solenoid, the turns are bigger. Understood? So the radius will decrease the magnetic field line. Got it? So it is inversely proportional to the radius. So MFS is inversely proportional to radius. Understood? So if the radius will be more, the magnetic field strength will be reduced. But if the solenoid is very small and turns are very heavy, then magnetic field strength will increase. Understood? Then magnetic field strength we can increase. And the next important point which we cannot avoid is the nature of core material. The nature of core material. The nature of core material used in making a solenoid. Understood? The nature of core material used in making a solenoid beta. Like soft iron is exactly will give a strong magnetism. Understood? So use of soft iron rod as a core will produce strongest magnetism. Remember this one. बेटा अगर सॉफ्ट आयरन कोर वी विल यूज, इसके अंदर अगर एक सॉफ्ट आयरन बार हम डालते हैं, सॉफ्ट आयरन कोर. ओके, सो यूज ऑफ सॉफ्ट आयरन कोर will increase magnetism, strongest magnetism. It will increase or it will become a strongest magnet. Understood or not? So this is very, very important. Huh? I don't know, beta, but I have to start. I'm having some other works also, so I started fast. So, beta, this is first the number of turns in the solenoid. So, if the number of turns in the solenoid will increase, magnetic field strength will become more. Okay. Second part is the strength of current. If the current produced here, the current exactly generating here is more, potential difference is high, current flow is more, then also the magnetic field strength with the magnetic field lines will be more. Third is if you will increase the solenoid length, then magnetic field strength will reduce. Okay. And the fourth one is the core material inside, because it will also, this is the one, the core material, what it is using inside now, like soft iron, steel material, when you will be using inside like as a core rod, like which will be exactly representing the magnetic effect that will be. ठीक है बेटा. सो हेयर कुछ नहीं बोल सकते, सबको चिल्ला चिल्ला करके जितना क्वेश्चंस पढ़ाया था सब आ गया, अब क्या ही बोल सकते हैं. स्टार्टिंग से मैं चिल्ला रही थी सबके ऊपर, किसी ने सुना नहीं. सारा क्वेश्चंस का मैंने निकाल दिया कि जितना क्वेश्चंस कोचिंग में कराया था उसमें से मैक्सिमम क्वेश्चंस लड़ गया. नाउ इलेक्ट्रोमैग्नेट, अब shall we start electromagnet beta? So now we are going to first talk about electromagnet. बोलो विश्वजीत, कैसा गया मैथ्स पेपर बेटा? So shall we go for electromagnet beta? Now it is exactly what type of magnet? There is two type of magnets we say. One is called as permanent magnet and one is called as electromagnet. So electromagnet is exactly a temporary magnet. Understood? An electromagnet is made with solenoids. We can say like that. Yes, that is passing electricity in a wire, keeping a soft iron core inside it, then the magnet generated, the magnetic field generated will be considered as electromagnet. It will be considered as what beta? Electromagnet, and this electromagnet is a temporary magnet. So just check this one out. Where is electromagnet? This is electromagnet. And about bar magnet. Now, bar magnet is exactly definitely will be told as this is a permanent magnet, north and south pole. But when we are making electromagnet, one core we are taking and we are allowing the solenoid to pass through it. and conduction of current will be exactly around it. So this will be considered as electromagnet. So electromagnet will be two shape. One will be horseshoe shaped will be there. That is also considered as electromagnet when the wire turning will be exactly taken like this, and then a magnet will be generated. So this will be considered as, this is horseshoe shaped magnet. So these two, they are temporary magnets. But bar magnet is permanent magnet. This is the difference. Electromagnets are temporary magnets. Okay. So temporary in insulated copper wire coiled around an ankle connected to the circuit. Yes, that is exactly called as electromagnet beta. So electromagnet definition I am not doing, roughly I am doing. So core of electromagnet must be soft iron. Understood or not? So why beta? It will be soft iron. What we are using here, it must be a soft iron. Why it should be soft iron? Can we take steel? Understand why the core of electromagnet is soft iron, why it is not steel. Many times they are asking this question. The answer to this question is, if you will take steel or any other material, then when the current will flow through it, then this will act as a magnet. But once the current flow supply will be switched off, steel will become permanent magnet. It will not lose its magnetic effect. Are you understanding? So if I am going to use steel, it will become a permanent magnet. Understood or not? Huh? It will become a permanent magnet. Yes. So we want that type of magnet who can change its magnetic effect. Now, sometimes the magnetic field strength is more needed, then I can make a strong magnet. Sometimes for doing different work, we need different type of magnetic field. Understood not? Field strength has to be changed. So only we are taking a temporary magnet, na beta. So here if current, I want a very strong magnet for one specific work. Understood not? So that time I will increase the current. So if I am increasing the current, it will become a strong magnet. If I am reducing the current, it will become a weak magnet. Understood not? That means I can change the magnetic field strength. Understood? But here I can't do anything. It's fixed. Got it? So I can't use it for all purpose, but I can use it for all purpose. But how I am going to make it usable? If I am using soft iron inside, then it is usable for me. Why? It is usable for me because the iron, the moment the current supply will be stopped, the iron will lose its magnetic effect. The iron will lose its magnetic effect. But if instead of soft iron, I use any other material like steel, understood or not, iron, any other iron, then soft iron, it will not lose its magnetic effect. It will become magnet. Understood? That time, if I want to change the magnetic field lines, it will not show the same effect. It will exactly show rough scales. That is not good for us. Understood? We want it to work when only current supply is there. We don't want it to work when current supply is not there. The moment current supply is shorted out means the iron should stop showing the magnetic effect. We want that type. Are you understanding? So that we will get a correct amount of magnetic field lines. I explained it very nicely. Everybody understood or not? Come on, say yes. Did you understood na beta? So here we are using inside the solenoid what type of iron? Soft iron. Why we are using soft iron? Beta, because the movement, yes, it can be used for all purpose. Strong magnetic field also and weak magnetic field. But if I will use steel, it will get converted into permanent magnet. The moment current supply is stopped, till then it will act as a permanent magnet. So it will just show the magnetic effect after that also. So only soft iron is used. Understood? So now we are going to understand the next important point. Among these two, which one is having more strength? So among bar magnet or horseshoe magnet, the more effective one is horseshoe magnet because the field lines are very, very near. If you will see, the field lines are very, very near. So horseshoe magnet are more impactful in compared to that of bar magnet. Understood? in compared to that of bar magnet. I hope you might have understood. I hope. Okay, I'm seeing one question she is asking. Maha is asking one question, that soft iron is alloy. You are answering me or asking me? Ma'am, is soft, okay. Ma'am, is soft iron is an alloy? The answer is no. Actually, it is more pure iron, understood, in which the carbon content will be lesser than the usual cases. So we can say that the soft iron is more pure iron in compared to that of other irons, beta. It is not alloy. Okay, don't write it as alloy. It is exactly pure iron. I hope everybody understood. Hey, inform in the group, yaar, to join the class. Many people are absent. Hi, Sakshi. हाँ बेटा. I hope this confusion is clear. What is the difference between permanent and among the length of air gap between its pole is less. Because of that, it is a more strong. The length of air gap is less. So this is a stronger electromagnet in compared to that of bar magnet. Understood? So horseshoe magnets are stronger in compared to that of bar magnet. Understood? So it is a better and permanent magnet because it produces very strong magnetic field and its strength will be higher. Understood? And it will be exactly the turning in the coil will be changing the magnetic field lines. I hope this is correct, beta. So now another important thing is ki, very good. So here this is a permanent temporary magnet. This is a permanent magnet. Okay. So electromagnets are temporary magnet and this one is permanent magnet. So here, whenever somebody will say that permanent magnet is comparatively having weak force of attraction, remember. So permanent magnet will have weaker force of attraction between the magnetic field lines. Understood? But here we are experiencing stronger force of attraction. This is the most important point. One is having a weaker force of attraction, another one is having a stronger force of attraction. Okay. So here, this is exactly, first is permanent magnet, weaker force of attraction, temporary, this is stronger force of attraction is there. Third is, its strength of magnetic field cannot be changed. Here, strength of magnetic field can be changed. Understood or not? Now, north-south polarity also we can change. Here, north-south polarity can be changed. Here, north-south polarity cannot be changed. How we can change? We cannot change the north-south polarity, because north will remain north, south will remain south. But if we will change the direction of current, then north-south polarity can change. So this is the most important point between electromagnet and bar magnet. So now permanent magnets will be exactly made with alloys, but bar magnet, see, permanent magnets are exactly made with alloy. Remember this one: carbon steel, chromium steel, cobalt steel. If we will use that one, we will make permanent magnet. Okay, tungsten steel, alnico steel, they will be always making a permanent magnet. So permanent magnet is made with alloy, because Maha has asked this question. So I'm just explaining this one. Are you ready, beta? So what and all permanent magnet I can make with? So permanent magnets are made with alloy. That is different. Permanent magnet means carbon steel. This is steel beta, carbon steel. If you will allow current to pass through carbon steel, it will become a permanent alloy. After that, right, chromium steel. Understood. Chromium steel, carbon steel, cobalt steel, tungsten steel. All they are exactly making what type of magnet? Permanent. But soft iron, which is a pure iron, less amount of carbon is there, it will be soft iron. Understood or not? And they will never make a permanent magnet. Got it? So how can we, magnet can be used everywhere, speaker and many things we are using magnet, correct now? But beta, how can we destroy a magnet? Come on, tell. Heating, breaking, hammering, and changing the direction continuously. Understood or not? So see, 2-3 magnet you bring near a magnet and try to change the direction of that 2-3 magnet again and again. Understood? Keep on changing the directions of the magnet. If the magnetic field lines will get disturbed, means it will lose its magnetic effect. Understood or not? Burning also will lose the magnetic effect. I hope you might have understood this one. Yes, breaking, no beta, burning. Burning, yes, breaking, continuously breaking, unwanted shape changing will also move the direction. If we will keep on changing the direction, is exactly coming to change the effect of magnet. Yes, yeah. Burning also will change. Changing of direction, continuous change of direction also you will be putting means the magnetic field strength will change. Understood? Now, beta, another point is magnetism in human being. So, do you think that your body is generating some magnetic effect? How you wrote, Mukundan? How you wrote? How was your maths examination here? Sanjay, how you wrote maths? You did not called me. You did not told me nothing. You told. You people did not informed me one thing also. At least one call is needed. So now I want to ask one question. Does human generate a magnetic field? See, don't go to aura or something unwanted things I don't want to hear. Many people, not good, ma'am. Why? What you did? Did you left questions, Sanjay? See, the body is exactly having sodium ion, potassium ion, zinc. So whatever ions that is present in the body, moving in the blood, they generate a weak magnetic flow because magnetic effect will be there. These ions, what? Still now I did not release the solutions. Don't get disheartened by all these things. Total how much you are expecting that you need to see. Rest of the part has to be seen. We did much of revision, yaar. Just don't get disheartened. Sanjay, focus in science now. Now look here. You need to understand that this weak ionic current that is generated inside the body, they will exactly generate a magnetic field. So yes, that will generate. So now what and all are the two organs that will be significant to show that magnetic field? Significant to, can you tell me the two main organ of human being where the magnetic field produced is quite significant? Can you tell me the name of the two organs where the magnetic field generated is quite significant? Blood flow is exactly generating. The blood flow will be in one direction. That is also one of the reason of generation of magnetic field around you, because it is in a unidirection going from heart towards body, body towards heart. So because of that movement also magnetic field generation is there around your body. It is not so strong, it's a weak magnetic field. But which are the two very pronounced organ of the body where the magnetic field effect is very high? You can feel the magnetic field strength. Can you tell me the names of that part, beta? Maha has given the answer heart and kidney. Heart is correct, but kidney is wrong. No, no. Heart is correct, but kidney is wrong. Yes, Kritika. The correct answer is heart and brain. So brain is exactly having, yes, heart and brain. You need to remember that the significance, because electrical impulses are generated. So these electrical impulses quite high in brain and heart. Understood? So I taught you in heart, sinoatrial node I taught now. That is, it will exactly start the rhythmic contraction and relaxation. The rhythmic contraction and relaxation are because of the SA node. Understood? NASA nodes are there which will increase the heart rate or which will reduce the heart rate. There you will see an impact of what? There you will see an impact of magnetic field generation. Understood not? So you know when you will be going in a magnetic region, your heart rate will increase. You know, because your heart is exactly showing some strength of magnetic field around. Understood not? So that strength will mix up with that strength. So because of that, the heart rate increases. Understood not? So another point is MRI. Do you know what is the work of MRI, beta? Yes. So MRI is magnetic resonating index. Understood not? So here that one machine is there, that is exactly index, I'm saying imaging. So magnetic resonance imaging. So that imaging machine, MRI machine, will definitely work on that. It is having a very strong magnetic field inside it, and in that they are exactly capturing. So electromagnetic field lines will pass, yes, and that will be generating, means whatever images will be there now, because our also having a magnetic field lines. Understood not? When we'll go into MRI scan room, there the high magnetic field regions will be able to tell us about the organ functioning. Understood not? So only MRI scan room. So many accidents are happening in MRI scan room. There they are saying metal objects should not be taken because they are generating a very high amount of magnetic field. Understood? Because the high amount of magnetic field will pass through our body, and then any damage or any functioning in the organ, because the blood is also having that magnets. Understood? The ions are there, and that ions will easily capture that part. Now one thing we learned, that the current moving in a wire can generate a magnetic field. Correct now? Now we are going to understand the concept of induced current. Can you tell me what is the meaning of induced current? What is the meaning of induced current? Induced current. Unit charge. Induced current is not that, beta. If somebody will be asking you what is the meaning of induced current, now we will understand the meaning of induced current. Just get this point as कि one wire I have taken, and at the time of teaching electricity I have explained you this is a galvanometer. Okay, we are going to put one galvanometer. Now once this galvanometer is near, this wire is not having any type of battery or cell. Potential difference is not there in the wire. Okay, one galvanometer is there. What is the galvanometer work? To measure the amount of induced current flowing in the circuit. To measure the amount of induced current flowing in the circuit. So beta, for this what we need, one wire is taken and one galvanometer fixed, but it is not going to work. We are going to take one magnet, bar magnet, and this bar magnet has to keep on coming and going near from that wire. So if we will keep on changing the direction of this bar magnet to and fro, continuously we will do that, then what will happen? See this wire, inside the wire you know that electrons are there, correct? No? So this change in magnetic field lines will disturb the electrons that is present, the ions present inside it. And these ions, when they will start dancing, they will start moving in a unique pattern. And this movement of the charged ions, because of the movement of magnetic field, will generate a current in the wire. The electron will start moving around the wire, understood or not? And the movement of this electron will exactly induce a current inside the wire, and that is called as induced current. This current is not because of a potential difference. This current is generated because of the movement of magnetic field. This current is generated because of the disturbance of magnetic field. So this magnetic field has created the ions or the electrons present in a circuit to move in a uniform direction. So till this magnet will come to and fro motion, till this magnet will move, the electron will start moving in the circuit. So one time will come when the electron will, this magnet, if you will remove it, the electrons will stops moving, and that time the galvanometer will stop. Understood or not? So this is exactly the concept of electric motors, generators are exactly based on induced current. I hope you might have understood the concept of induced current. Huh? So this is exactly the most important thing. Now we are going to talk about, I'm asking you a question. Everybody, can you answer my question? My question is, when a current carrying conductor is placed in a magnetic field, when a current carrying conductor is placed in a magnetic field, what will happen? When a current carrying conductor is placed in a magnetic field, what will happen? See, magnetic field will itself have its field lines, correct? Now, one example was there, that drawing, I think one time many people have asked me about this drawing. So today I'm going to explain you about this drawing. So now listen better. Sometimes lines are there because 2-3 lines are there, na, so only this is affecting. Charges are there, na? Yes. Signs. Yes, electromagnetic field lines will be generated, beta. We will take one horseshoe magnet. Understood or not? So horseshoe magnet will be showing one north pole, and this side it will be showing as south pole. Done. After that, we are going to take one mercury. Mercury is a metal, na? We are going to keep mercury here, and then one wire. And that one wire will be there. This wire. Yeah, liquid metal. So only we took like that. And then one jack in that wire is exactly connected. So this part of the wire, one wire fix we will take like this. Both the wires are dipped inside. Now here, understand not? So this part, so the moment you will be seeing that the moment the circuit will close, the moment I am going to close the circuit is open. So till the circuit is open, listen here, till the circuit is open, the magnetic field lines are not disturbing anything. This is a movable wire. This wire is movable. This is mercury is inside, Hg is inside, liquid metal. Understood now? Other metal taking means we cannot change it. So now look here, beta. So what we are going to do, this is a movable wire. So this movable wire will do what, beta? The moment you will close the circuit, immediately what will happen? Because see, magnetic field will have its magnetic lines of forces. Already this magnetic lines of forces are there. It will not stop. Understood? Horseshoe magnet will have its magnetic field lines. Understood? But the moment you will close the circuit, this will also have its magnetic lines of forces. So the moment it will start having its more magnetic lines of forces. So two magnetic lines of forces will clash with each other. The moment the magnetic lines of forces are clashing with each other, what will happen? The wire will disconnect and go up. So this will push, the magnetic lines of forces will push the wire and open the circuit. Are you understanding? It will push the wire. Thank you so much. It will push the wire and open the circuit. So this is exactly an indication that only electric field is exactly generating magnetic field, magnet is generating magnetic field, electric is also generating, and they both are perpendicular to each other. And that's what is the Fleming's left hand rule tells about. Understood? And that's what is Fleming's left hand rule is telling about, and it is like this. Correct or not? This is magnetic field, this is current, and this is force or motion. The thumb is showing force, this is magnetic field, and current is going down. So this is Fleming's left hand rule. I hope this indication is enough for understanding. Children, did you understood now what is actually happening? This wire now will start conducting magnetic field around it. The moment it will conduct, so this magnetic lines of force and that magnetic lines of forces will clash each other. Yes, and the moment it will do like this, the wire will come out from it. The wire will come out from it and the circuit will become open because two magnetic forces are clashing with each other. I hope it is clear. So this is exactly exerting a mechanical force, beta, and that means what? Fleming's left hand rule means the force will be perpendicular to electrical and magnetic field. This is magnetic field, current, and this will be the field of force generated between them. And this is called as what? This is called as Fleming's left hand rule. Understood? Electric motor is not in the syllabus, na? Electric motor and generator is not in the syllabus. Quickly inform me. In your NCRT book, electric motor generator is there? There or not there? You say like this. Oh, you're not studying. That's the biggest thing. AC and DC current is there. Okay. So AC and DC, that is alternating current and direct current and household circuit. So beta, one more video. Tomorrow we are going to start. Tomorrow you are going school, not going school, inform me immediately. For blessing school, school is there. I don't know school is there or not. They'll only inform. Okay, if not going school means 11 o'clock or 12 o'clock. Sharply 12 o'clock I will start the class. One AC DC current supply I will teach, and then evening class we will study. Okay. I'm keeping it till here, beta. Bye bye. You go.